Hi, this is Manjira Kara. I'm from Texas A&M University, Kingsville. I'm doing my master's in computer science. Today, I would like to give a brief overview of machine learning, and my advisor is Dr. Eng Lee. First topic, it's what is machine learning. In machine learning, actually, it's a subfield of computer science that gives computers the ability to learn without being explicitly programmed. Machine learning is closely related to computational statistics, which also focuses in prediction making through the use of computers. It has strong ties to mathematical optimizations. Within the field of data analytics, machine learning is method used to devise complex models and algorithms that lend themselves to prediction. A branch of artificial intelligence concerned with the design and development of algorithms that allow computers to evolve behaviors based on empirical data. And a computer program is said to learn from experience with respect to some class of tasks and performance measured if its performance at task as measured improved with experience. This is not notable for its defining machine learning in fundamentally operational rather than cognitive terms. Learning, it's the learning system model. The main thing that we use in this learning system model is testing and training. The input samples it send the like if you take like algorithms, if you take an example algorithm, it sends to the learning method, and then it trains the method to the system, and it it divided and then it divided into the type of the problems and the task. Machine learning tasks are typically classified into three broad categories. We will explain in the next slides. So we will see the performance of that. There are several factors affecting the performance: types of training provided, the form and extent of an initial background knowledge, the type of feedback provided, the learning algorithm used. Yeah. And the two important factors are modeling and optimization. And the algorithms I told you the before that we use here are the success of machine learning system also depends on the algorithms, and the algorithms control the system to find and build the knowledge structures. The learning algorithms should extract useful information from training examples, and these are: the first one, it's supervised learning. The computer is presented with example inputs and the desired outputs given by a teacher, and the goal is to learn a general rule that maps inputs to outputs. So it's saying like the first one is prediction and the classification. It describes about the discrete labels, and the regression it describes about the real values. And the unsupervised learning, no labels are given to the learning algorithm, leaving on its own to find structure in its input. And unsupervised learning can be goal in itself or a means towards an end. The unsupervised learning, it training data does not include desired output. So it consists of the following, like clustering, probability distribution estimation, finding association, dimension reduction. And the next topic is semi-supervised learning. It's a training data includes a few desired outputs. And the same thing with the unsupervised learning. So the next one is reinforcement learning. It's rewards from sequence of actions. It means, for example, it's decision making robot, or for example, for the decision making is robot and the chess machine. Some difference but between and unsupervised is that here it has the predictive model, but here it's just the model that gives likelihood or cluster ID or better representation than the supervised learning. And the supervised learning, here if you see here, the we get the equation out there with the error and the e out, e in and e out. E in is for training set and e out is for testing set. We have discussed it before that the main things that learning techniques we use here is first is training and the second is testing. Both the techniques we used in all algorithms. So in supervisor, low e output or maximum probabilistic terms. and unsupervised minimum quantization error, minimum distance map MLA, maximum likelihood estimations. And here what are you seeking about this is, here is the graph that shows the E out and E in graph, which differs between the error and the DVC. So unfitting versus overfitting fixed. And here if you see, there is a lot of difference between the E out and E in, and which comes to null, and E out is the model complex. It's the model complexity, that is the model equal to hypothesis plus loss functions. And here it's a brief discussion about the supervised learning categories and techniques. And the first one is linear classification. Here in the linear classification, it's quick, simple classifier and outputs a probabilistically labeled confluence. Like the linear SVM is used in Naive Bayes algorithm. This is a simple thing to try for categorical data, very fast to train and test. Maximum likelihood of label given data assuming a long linear model, which gives there's a graph between a male and a female, that height on the pitch of the voices. If you take an example for that, I'm giving an example for that, but using logistic regression, it's a quick simple classifier. And classifiers like linear SVM, finding a linear function to separate the classes, it's like f of x equal to SGN of w into x plus b, and the linear SVM is fine for by the function. And there we go to the non-linear classifiers. And the categories techniques used, the second one is parametric, which is probabilistic functions. The Naive Bayes uses this, and using the GDA, HMM, probabilistic graphical models. And we have the other side, we have the non-parametric, which is instant based functions. We use like lot of kernel functions, kernel k-nearest neighbors, kernel regression, kernel density estimation, local regression. It's like non-linear kernel, the same thing with the non-linear kernel, and the data sets that are linearly separated work out greater. But if the data set is just too hard, we can map it to the higher dimensional space. The original input space can always be mapped to some higher dimensional feature space where the training set is separable. The kernel trick, that is what kernel trick, instead of explicitly computing the lifting transformation, define a kernel function case such that if there is a function for nonlinear SVMs, this gives a nonlinear decision boundary in the original feature space. And if you go to the non-metric, it's a symbolic function, classification and regression tree, decision tree, aggregation, bagging, bootstrap, and aggregation. And here we see the example, I said it before, like if you take like the female and the male, there is a separate function for that, where here it's saying the g of xn is equal to sine wt xn, where w is an d time vector. So these are the techniques like perceptual, logistic regression, support vector machine, Adeline, multi-layer perception. It was all decreased and the error rate was increased. Here in the same case with the non-linear case, I said the example. If you come back for the unsupervised learning category, learning classifier systems are a family of rule-based machine learning algorithms that combine a discovery component with a learning component. They seek to identify a set of context-dependent rules that collectively store and apply knowledge in the piecewise manner in the order to take predictions. And if you come for the applications, in 2006, the online movie company Netflix held the first Netflix prize competition to find a program to better predict user preferences and improve the accuracy on its existing Cine Match provide movie recommendation algorithm by at least 10%. A joint team made up research from AT&T Labs, research in collaboration with the terms Pictures and Programmatic Theory built an assemble model to win the grand prize. This one, they changed the recommendation engine accordingly. So the applications, some of the applications like adaptive websites, effective computing, bioinformatics, brain machine interfaces, and some of the interesting ones that nowadays the children likes the game playing, and the business magnets like marketing, all these are depend upon the machine learning algorithms, and which are like economics, online advertisement, robot locomotion, search engines, sentiment analysis, and software engineering, syntactic pattern recognition. A lot of applications are there. Some of I listed here are detection. Yeah, face detection, it's if you go like it's ID identification. If you go somewhere else like a passport identification, um, this one, it depends upon the machine learning. So the next one is object detection and recognition, image segmentation, multimedia event detection, economical and commercial use. And classification machine learning models can be validated by accuracy estimation techniques like holdout method, which places the data in a training and test set. And so conclusion, we have a simple overview of some techniques and algorithms in machine learning. Further, there are more and more techniques apply machine learning as solution. In the future, machine learning will play an important role in our daily life. For sure, it will play an important role because if you see for the applications, if you see there are a lot of things that the machine learning have lot of applications by using those. So this is what the machine learning, and these are the references I got for the preparing my PPT. And thank you.